Hi, today we're going to be learning about solving problems with triangles. To start off by quickly reminding you about the properties of triangles that we're going to be using as we solve problems. The first property is that the interior angles of a triangle will add up to 180 degrees. So I can say that in this triangle over here, angle A plus angle B plus angle C is equal to 180 degrees, and my reason will be the sum of the angles in triangle ABC. Okay, the next property is that the exterior angle of a triangle is equal to the sum of the opposite interior angles. So in this triangle over here, I can say that the exterior angle, which is angle C2, is equal to the sum of the opposite interior angles, so angle A plus angle B. And my reason for being able to say that is because of the exterior angle of triangle ABC. The next property is that the angles in an equilateral triangle are all going to be equal to 60 degrees. So I can say angle A is equal to angle B is equal to angle C, which is 60 degrees. And my reason for that is because this is an equilateral triangle. So it's angles of equilateral triangle ABC. Remember, an equilateral triangle is a triangle that has all three sides equal in length. Our next property is that the base angles of an isosceles triangle are equal. Now remember, an isosceles triangle is a triangle where two sides are equal in length, and the base angles are the angles that are opposite those equal sides. So they won't necessarily be at the bottom of the triangle. If the triangle is turned around, the base angles are still the angles that are opposite the equal sides. So I can say that angle B is equal to angle C in this triangle, and my reason is because they are angles opposite equal sides in triangle ABC. Then conversely, if two angles of a triangle are equal, then the opposite sides are equal and the triangle is isosceles. So in this triangle over here, you've been told that angle B and angle C are equal to each other, which means that AB will be equal to AC because they are the sides that are opposite those equal angles. So I can say AB is equal to AC, and my reason is sides opposite equal angles in triangle ABC. Then finally, we have right angle triangles. A right angle triangle has one angle that is a right angle, and the side opposite the right angle is called the hypotenuse. Remember, we have the Pythagorean theorem, which helps us to work out the lengths of the sides in a right angle triangle, which states that in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. Okay, so now that we've gone through all the properties of triangles, let's go on to an example where we're going to be solving a problem using these properties. In this example, you've got triangle ABC and triangle ACD coming together to form triangle ABD. You've been told that AB is equal to AD and AC is equal to CD, and angle D is 30 degrees. And we need to work out the sides of X and Y. Okay, so let's have a look at how we would do this example. Okay, so here I've got my diagram over here. Now remember, before we actually start, you have to remember that when you are doing a geometry problem, for every single statement that you make, you have to give a reason that explains why you can make that statement. Okay, so the first thing I'm going to do is work out X. Now in order to work out X, I need to look and see what information I've got. I need to work out the size of X. The only size that I know at the moment is angle D is 30 degrees. So I need to figure out how I can use that to work out what X is. So what I can do is I can look and see, okay, this 30 degrees is an angle in this triangle over here where these two sides are equal to each other. It's also an angle in this triangle where these two sides are equal to each other. So I might be able to use that as well. But for now, X is sitting next to this triangle. It is an exterior angle of triangle ACD. So because it's an exterior angle, remember we know that the exterior angle is equal to the sum of the opposite interior angles. So this X is going to be equal to angle A1 plus angle D, which is 30 degrees. I don't know what angle A1 is yet, but if I can work that out, then I'll be able to work out what X is. So what I'm going to do is I'm going to say in this triangle, because I know that this side is equal to that side, angle A1 is going to be equal to 30 degrees because they are angles opposite equal sides in triangle ACD. Okay, so that's what I'm going to say over here. So for this example, I can start off by saying that angle A1 is equal to 30 degrees. Okay, and my reason is because they are angles opposite equal sides and this triangle that I'm working with over here is triangle ACD. I'm specifying which triangle I'm looking at because there's more than one triangle in this problem, so it helps the person who's marking to know what I'm actually talking about and what I'm actually looking at while I'm writing that. Okay, once I have done that, I can go and fill it in on my diagram, and now I can use it to help me to work out other things after this. Okay, so now I've got that's 30 degrees and this is 30 degrees. And I said that x is the exterior angle of triangle ACD, which means that it's going to be equal to the sum of the opposite interior angles. So x is going to be 30 plus 30, which is 60 degrees. Now I can say, therefore, x is equal to 60 degrees, and my reason is because it is the exterior angle of triangle ACD. Okay, so now I know what x is. It is 60 degrees. Okay, so now I'm going to go and try and work out what y is. So to work out y, we need to look at where y is in the diagram and see what possible methods we could use to actually figure it out. So first of all, y is sitting inside triangle ABC. It's an interior angle of a triangle ABC. So if I know the other two angles in that triangle, they can help me to work out y because I can use the sum of the interior angles of triangle ABC. And the same thing for triangle ABD, because I know what this part of triangle of angle A is. I know that that's 30. If I can work out what B and D are, then I can work out what the whole of angle A is, and that'll help me to work out what y is. So I have two options. Both of those involve the sum of the interior angles of a triangle. And for both of them, I need to know what angle B is. So at the moment, I don't know what angle B is, but I can work it out because if you look at the whole of triangle ABD, I've been told that AB is equal to AD, which means that this is an isosceles triangle. So the angles opposite those equal sides will be equal to each other. That means that angle B will be equal to angle D, which is 30 degrees. So I can say that angle B is equal to 30 degrees, and my reason for that is because those are angles opposite equal sides in triangle ABD. Okay, so now that I know that, I can go and fill it in on my diagram. So this is 30 degrees over here. That means I can now work out what angle y is. I can work it out using this angle over here, the 60, and this 30, and the y in triangle ABC, or I can work it out using the whole of triangle ABD with 30, the 30, and then the y plus 30 over here. It'll be easier to use triangle ABC, so that's what I'm going to use. So I'm going to say that y is equal to, so now I have to go and work this out. So it's 180 minus the other two angles. So it's minus 30 and minus 60, and that gives me 90 degrees. So y is equal to 90 degrees, and the reason I can say that is because of the sum of the angles in triangle ABC. So that's how you work out y in that example. Okay, so now I'm going to give you a few that you're going to do for yourself. Here's the first one that you're going to do. In this example, you've got triangle PQR, where PR has been extended to S, and you've been told that angle P is 8x plus 60 degrees, angle Q is 2x, and angle QRS is 20x minus 40 degrees, and you need to work out the value of x. I'm going to give you 1 minute to work on this problem. Okay, so let's go through that example and see what you should have got. Okay, so first of all, in this example, I only have one triangle. I've been given this angle in terms of x, this angle in terms of x, and this angle in terms of x. Now this angle over here is the exterior angle of triangle PQR, where angle P and angle Q are the opposite interior angles. So that means that this angle is equal to that plus that. So I can say 20x minus 40 degrees is equal to 8x plus 60 degrees plus 2x. And the reason I can say that is because of the exterior angle of triangle PQR. Okay, now we need to go and solve for x. So I've got 20x minus 8x minus 2x. That gives me 10x over here. And then on this side I've got 60, and I'm going to take this across, and that becomes plus 40. So that's 100 over there. And then I'm going to divide by 10, so therefore x is equal to 10 degrees. So that's what you should have got for question A, that x is 10 degrees. Right, let's go on to question B. In question B, you've got triangle ABC, which is divided into two triangles, ABE and BCE, and BC has been extended to D. And you need to work out the values of x, y, and z. I'm going to give you 3 minutes for this question. Okay, so let's go through that example and see what you should have got. So in this example, you had to work out x. Okay, now to work out x, you can look at the information you've already been given. You've been given that this angle over here is 15 degrees and this angle over here is 110 degrees. This 110 is an exterior angle for triangle ABC, and it's also an exterior angle for triangle BCE over here. Now x is in triangle BCE, and it is one of the opposite interior angles for that exterior angle. The other opposite interior angle is this one over here. So we've got this opposite interior angle, we've got the exterior angle, and we need to work out x. So I'm going to be using the exterior angle of triangle BCE to work out what x is. So for question B, I can say that x is equal to, now remember, because these must add up to that, I can say this minus this one must be x. So it's 110 minus 15, which is 95 degrees. So that is because of the exterior angle of triangle BCE. Okay, so once you've worked that out, you can go and write it in on your diagram. So this is 95 degrees. Okay, the next thing we need to work out is the size of y. So now y is sitting over here. Now, you have a couple of options for working out the size of y. You can use the interior angles of triangle BCE because we know the size of this angle and the size of this angle. So now we can work out y. Or you can use angles in a straight line. Now, at the moment, we are focusing on the triangle, so I'm going to be using the interior angles of the triangle, but if you use angles in a straight line, that's fine as well. Okay, so what I'm going to say is y is equal to, remember the interior angles of the triangle must add up to 180, so it's 180 minus 15 and 95, and that gives me 70 degrees. So that is because of the sum of the angles in triangle BCE. But like I said, if you had angles on a straight line as your reason over here for working out y, then that would be fine as well, because it's on a straight line with 110 over there. Okay, so this is 70 degrees, and I can go and fill it in on my diagram. Now next, I need to work out what z is. Now, once again, I have more than one option or method that I can use to work out z. Z is an angle inside triangle ABE, so I could potentially use the interior angles of that triangle, or I could use the exterior angle of that triangle because I've got 95 degrees over here, this x, which is an exterior angle of that triangle, and z is one of the opposite interior angles, in which case I need to know what angle A is. Or I could use the angles inside triangle ABC. I've got this angle, I can work out what that one is, and then I can use the z and the 15 together as my third angle over here to work out what z is. Either way, I have to work out what angle A is. I can't get away from that. So I'm going to go and work out what angle A is. In triangle ABC over here, A is opposite BC, which is equal to AB, which is opposite Y, which we worked out already with 70 degrees. So I can say that A is going to be equal to 70 degrees because these two angles are opposite equal sides in triangle ABC. So I can say that angle A is 70 degrees. And my reason is because it is angles opposite equal sides in triangle ABC. Okay, so now I can go and fill that in over here. So that is 70 degrees over there. Okay, so now that I've got the size of A and I've got x over here, which is 95, I can use the exterior angle of the triangle to work out z. Or like I said, we can also use the interior angles of triangle ABC to work out z as well, because I've got that, and I've got that, and I've got this, which means I can work out what's left over here of angle ABC, which is z. Okay, I'm going to use the exterior angle option because it's easier, but that's not the only way you could do it. If you use the interior angles of triangle ABC, that's fine as well. Okay, so I'm going to go and say that z is equal to, so these have to add up to 95 degrees. So 95 minus 70 must give me z, so that means that z is going to be 25 degrees. And my reason is because of the exterior angle of triangle ABE. So that's what you should have got for question B, that x is 95 degrees, y is 70 degrees, and z is 25 degrees. Okay, now we're going to go on to question C. In question C, you've got triangle ABC, where angle B is 75 degrees, and angle BCA is 30 degrees, and you've been given triangle ACD, where angle CAD is 20 degrees. You've been told that AD is equal to BC, and you need to work out the size of x and the size of y. I'm going to give you 3 minutes for this question as well. Okay, so let's go through that question and see what you should have got. Right, so first of all, we had to work out what x is. Now, x is an angle inside triangle ABC, and you can see that we've been given both of the other two angles in that triangle, so we can use the sum of the interior angles of triangle ABC to work out what x is. So I can say x is equal to, so it's going to be 180 minus 75, and also minus 30 degrees, to leave me with x, which is now 75 degrees. Okay, and my reason for knowing that is because of the sum of the angles in triangle ABC. Okay, so now I can put that on my diagram over here. Now I need to go and work out what y is. Now to work out y, I don't have any exterior angles that I can work with over here, because none of these angles are made by sides of a triangle that have been extended. So the only option I have here is to work with the interior angles of triangles, or potentially isosceles triangles. But if you look over here, this side they told me is equal to that side, but they're not sides of the same triangle, so that's not going to help me either yet. But if you look at what we just worked out over here, this angle they told me was 75, and I just worked out that this angle is 75 degrees. So remember we said that when you've got an isosceles triangle, the angles that are opposite the equal sides are going to be equal. But you can also go the other way around and say, if you've got a triangle where you've got two angles that are equal, then the sides opposite those equal angles will also be equal. So now I can say that because these two angles are equal to each other, the sides that are opposite those angles will be equal to each other. So this side over here and this side over here are opposite the equal angles, which means that these two sides must be equal to each other. So now I can say that AC is equal to BC because they are sides opposite equal angles. In triangle ABC. Okay, so now I know that this is equal over here, but they told me that AD was equal to BC. That was given. Okay, so therefore that means that AC over here must be equal to AD as well, because they're both equal to BC. So now I know that these two sides are equal to each other, and because those two sides are equal to each other, it's an isosceles triangle, which means that the base angles will be equal to each other as well. So now I can say that angle D is going to be equal to Y. And my reason is because there are angles opposite equal sides in triangle ACD. So now I have over here a Y and a Y and 20 degrees. Now I can go and work out what Y is equal to, because those are the angles inside the triangle ACD. So I can use the sum of the angles in triangle ACD. Because these are both Y, I can shorten my calculation a little bit by saying Y is equal to 180 degrees minus 20 degrees divided by 2, because there are two Y's. So if I take 180 and I subtract the other angle, I'm just going to divide it by 2 to get each one of those. So it's 180 minus 20 divided by 2. My reason is because it is the sum of the angles in triangle ACD. Okay, so now we can go and work that out. So 180 minus 20 degrees is 160, divided by 2 is 80 degrees. So that means that Y is equal to 80 degrees. So that's what you should have got for question C, that X is 75 degrees and Y is 80 degrees. Okay, now we're going to go on to the last one for today. In question D, you've got triangle ABE, where they've told you that AB is equal to BE, which is equal to AE. And you've got triangle BCD, where they've told you that angle C is 20 degrees, and you need to work out the size of X, Y, and Z. I'm going to give you 2 minutes for this question. Okay, so let's go through that question and see what you should have got. Right, so first of all, you have to work out what x is. Now, x is sitting inside this triangle ABE, where they've told us that AB is equal to BE, which is equal to AE. So we have over here an equilateral triangle because all three sides are equal. This is the only time where you're going to be able to work out the size of an angle without needing to know any other angle sizes to help you. This 20 degrees over here isn't going to help you at all to work out what x is because it's completely separate. It's in a completely different triangle to what x is. But we don't need it because this is an equilateral triangle. And in an equilateral triangle, we know that all three angles will be the same size and they will all be 60 degrees. So I can say that x, so for question D, x is equal to angle B1, which is equal to angle E1, which is 60 degrees. So all three of those angles are 60 degrees, and the reason is because they are angles in the equilateral triangle ABE. Okay, so now I can go and fill the 60 in for all three of those. So this is 60 degrees, this is 60 degrees, and this is 60 degrees. Okay. So now I've worked out what x is. The next thing I need to work out is y. Now you have two choices. Again, you can do angles on a straight line. I'm not going to be doing that option because I'm focusing on triangles at the moment. But if you use angles on a straight line, that's absolutely fine. I'm going to be using the exterior angle of triangle ABE. It's equal to the sum of the opposite interior angles. So y is going to be equal to 60 plus 60. So I can say y is 120 degrees. And my reason is exterior angle of triangle ABE. Okay, so this is 120 over here. Now I'm going to go and work out what z is. Now again, I have two options. I can work with the interior angles of triangle BCD, or I can work with the exterior angle of triangle BCD, because this angle B1 over here is an exterior angle and it must be equal to that plus that. So you have two options here again. Okay, it doesn't matter which one you use. So z is going to be 20 plus z must give me 60, so z must be 40 degrees, or 180 minus 120 minus 20 will also give you 40 degrees for z. So it doesn't matter which one you use. It could be sum of the interior angles of triangle BCD or exterior angle of triangle BCD. It doesn't matter. So you should have got, for question D, that x is 60 degrees. We use the equilateral triangle to work that out. Y is 120 degrees. I used the exterior angle of a triangle to work that out. And z is 40 degrees. And I used the sum of the interior angles of triangle BCD to work that out. And that is how we solve problems with triangles. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.